So, hi all. I'm Kalaivani Vetrivel, working as an assistant professor, Department of Pharmacy, and in SNS College of Pharmacy and Health Science. So, today let's discuss a topic on uh, solubility of the drugs. In this, we'll see about solubility definitions and some of the terms involved in the solubility of the drugs, solubility expressions, and the mechanism of the solubility. So, what we'll see some definitions of the solubility. First, what is a solution? Solution is a mixture of two or more components that form a homogeneous mixture, and it is represented as the components. What are the two mixtures? The components are referred to the solute or solutes and the solvent or solvents. Uh, so let's see about the definition of the solute. So what is solute? The substance usually present in a lesser amount and getting dissolved in the solution, that is called as solute. Example, in a sugar and water solution, sugar is the solute and water is the solvent. So now, what is solvent? Next coming, solvent is the compound in which the solute is getting dissolved. As I said earlier, it is in a sugar and water solution, sugar act as solute and water act as a solvent. That is sugar dissolved in the water, solute dissolved in the solvent. That is the explanation. And next, we'll be having two types of solutions, that is saturated solution and unsaturated solutions. Let's see about saturated and unsaturated. See the diagrammatic representation, that is a solvent is getting dissolved with a bulk solute and the solution is formed. So now saturated solution, coming to the saturated solution, is nothing but a solution that contains maximum amount of solute at a definite temperature. It is maximum amount of solute, maximum amount of sugar dissolved in a water in a certain temperature, that is room temperature or anything definite temperature. So, and what is about unsaturated solution? A solution that contains more solute than the saturated solution, that is undissolved solute than the saturated solution at a definite temperature. Sugar won't be mixed or dissolved properly in the water, that is unsaturated solutions. I hope you understand the definitions of solute and solvent and saturated solution, unsaturated solution. So next we go about the solubility. What is solubility? Solubility is the ability of one substance to fully dissolve another substance under a specified condition. If we see about in quantitative way, it is the concentration of solute in a saturated solution at a constant temperature, that is solubility. Now let's go to the solubility expressions. First we see about normality, and it is represented as capital N. Normality is defined as number of equivalents of solute dissolved in 1 liter of solution. That is in equation, it is number of gram equivalents divided by volume in solution in liters. And the formulaic way, it is expressed as N is equal to M into N. It's number of gram equivalents divided by volume in solution in liters. So now molarity, coming to the molarity, and it is represented as capital M. Molarity is defined as the amount of moles of a compound dissolved in an amount of solvent, that is usually water, moles. In equation, it is represented as moles of solute by volume of solution in liters, and in formulaic way, it is represented as N by V, that is moles of a solute N divided by volume of solution in liters. So now coming to the molality. Molality is expressed in a small m, and it is defined as a molar concentration is the amount of substance dissolved in a certain mass of solvent that is moles of a solute per kilograms of a solvent, and it is expressed as the equation, that is moles of solute per kilogram of solvent divided by kilogram of solvent, and formularic expression it is expressed as mole per kg. And coming to the units of molality, the units of molality is equal to mole per kilogram. And mole fraction, what is mole fraction? It is defined as mole fraction is a unit of concentration, that is the number of moles of a component divided by the total number of moles in a solution. It is expressed as XA is equal to moles of A divided by total moles. Now, percentage by weight, that is W by W percentage. It is defined as gram of solute in 100 gram of solution, as both solute and solvent will be in solid form. Percentage by volume, that is V by V percentage, that is nothing but ml of solute in 100 ml of solution, that is both solute and solvent will be in liquid form. And finally, percentage by weight and volume percentage, that is W by V percentage, gram of solute in 100 ml of solution, that is solute will be in solid form and solvent being. So I'm coming to the mechanism of solute solvent interaction. We will be having only 3 steps, that is detachment of solute from bulk form, formation of vacant site in solvent, insertion of detached solute molecule in vacant site of the solvents. These are the 3 bulk forms. In this first step, the solute, that is bulk from solute bulk form, one molecule will may detach, and this further used in the solute solvent interaction. And in the next step, that is formation of vacant site in solvent. In this step, from the solvent, one molecule of the solvent gets free and created a vacant site. This is the vacant, and this vacant site is further used in solute and solvent interaction in the third step, that is insertion of the detached solute molecule in the vacant site. The detached molecule, the detached molecule come into the contact with the solvent. So this is the mechanism of the solution, and thank you so much.